Hello there! There's a topic almost everyone runs into when working with rigging in Unreal. Importing a rig created in another DCC and making sure it behaves properly inside Unreal. There are a few subtleties that can trip you up, and that's exactly what I want to break down in this video. And for this scenario, we'll be using Blender. So let's take a look at it. If you build your bond structure in Blender and want to handle rig logic and controls inside Unreal, you've probably run into issues with the armature, scale, inconsistency, and other stuff during imports. The round-trip process between Blender and Unreal can be tricky, so let's go through the steps to help you avoid some common pitfalls. First off, when you create your armature in Blender, there's one small detail that can cause problem later on. If you leave the default name Armature, Unreal might have trouble understanding the skeleton structure during imports. What I usually do is rename the armature to Root. Why? Because it directly affects the hierarchy Unreal sees. Here's the thing. Unreal treats the armature name as a bone in the hierarchy. That label gets pulled into the skeletal mesh assets and becomes part of the rig you'll use in Unreal. So instead of creating a separate root bone in Blender, I often let the armature itself act as the root. I find it simpler and works well in most cases. Of course, you can still add other bones like a body offset or a center of gravity bone if needed. But using the armature as the root helps avoid extra complexity during import. Also, don't forget, you can still edit names and reorganize the hierarchy directly inside the skeletal mesh editor in Unreal. I walked through that process in a previous video, so feel free to check it out if you want to see how to make those adjustments step by step. Regarding modifiers, you can generally leave them as they are in Blender and apply them automatically during exports. This option is enabled by default in the export settings, though there's usually nothing you need to change manually. We'll go over the exports window shortly, so don't worry. The one thing to keep an eye on is the order of the modifiers. For example, the mirror and armature modifiers should be placed first in the stack to avoid strange artifacts, especially where mirror geometry connects. Getting the order right helps ensure a clean and symmetrical deformation once everything is in Unreal. Now about the geometry itself. You can absolutely work with split pieces. It's totally fine, but it will require a bit more care when it comes to skinning. The important part here is assigning materials properly. Make sure each piece or group of pieces that you want to differentiate has its own material. This is how Unreal identifies and separates parts of the mesh after import, much like Substance Painter does. As for UVs, you have fully flexibility. Unreal even supports UDIMs thanks to its virtual texture system. Before exporting, it's also essential to apply all transform on your mesh. These steps is often overlooked, but it's crucial to ensure the model behaves predictably after imports. Another point to consider is how your mesh handles normal data. Ask yourself whether the surface should appear smooth or have hard edges. In Blender, this is controlled through a simple right-click, Shade Smooth or Shade Flat. I avoid using Auto Smooth as it often leads to incorrect normal interpretation in Unreal. The same goes for custom split normal data. Both are Blender-specific features that don't always translate well into other environments. Sharp edges, for instance, work great with Blender, but outside of it, the result can be quite different. Ultimately, this all comes back to solid modeling fundamentals. Being careful with topology, understanding how bevels and edge highlights will behave, and making sure you intentionally define which areas are smooth and which are sharp. If you want a smooth surface, use Shade Smooth, and if it's hard surface model, keep those edges flat and clean. No need to add extra edge loops unless necessary. You can even mix both styles in a single model. Blender gives you control over that during exports through the smoothing menu under the Geometry tab. The most important steps before exporting is this. By default, Blender works in meters, while Unreal uses centimeters. So if you export your character as is from Blender, it might seem okay at first glance, but once you start using control ring, for example, and generating controls, you'll hit some scaling issues. The mesh might appear correctly sized, but the skeleton won't be. That causes inconsistency in the default scale of any new control created in Control Rig. Here's a clear example. On one side you've got the default export with the scaling issue, and on the other, the corrected version using the fix I'm about to walk you through. Once your rig and geometry are all set up in Blender, start by applying all transforms, on both the mesh and the armature. Then scale the armature up to 100. Apply the transform again, but this time only on the armature. Finally, scale it back down by dividing it by 0.01, and that's it. When you export your character, the armature scales will now match what Unreal expects, and any control rig element will use a proper default scale. So again, it's not a general mesh scale issue, it's specifically tied to the armature. That's why focusing on the armature transform alone is the most effective approach, rather than tweaking the mesh scale. One last thing to check, naming conventions. Take the time to go over everything. Make sure the hierarchy is clean, names are consistent, skin weights are properly assigned to, geometry and material slots are all in order. It might seem tedious, but it will save you a ton of time down the line. At this stage, this is where I usually stop the Blender parts. Everything else I handle directly inside Unreal. And now I'm also working on a complete workflow that skips most of these Blender steps entirely. Everything from static mesh to a fully rigged skeletal asset is handled directly in Unreal. I can't wait to share more about that soon. Now let's jump into the export settings. The ideal format for this process is of course FBX. This format preserves geometry, the armature, skin weight, and even any shapes keys, or morph targets if you want. You may have set up on your mesh. When exporting, make sure you selected both the mesh and the armature. Then go ahead and export. In the export settings, I limit the output to the selection only, and I choose to include only the armature and the mesh. Under the transform section, I leave everything at the default values. As I mentioned earlier, the scale problem is handled at the armature level, not here. In the geometry section, Unreal is usually smart enough to interpret your normals correctly. But to avoid unnecessary warning message in the log, I switch the smoothing option to face. That clears up those warnings and ensures consistent normal interpretation. This is also where you can decide whether to apply active modifier. As I mentioned earlier, I usually leave that setting on, it works well in most cases. In the armature section, the key setting to check is add leaf bones. I always turn that off. Otherwise, Blender will add extra bones to the end of each bone chain and they are not useful for Unreal. As for animation, I disable it here because I rarely create any animations in Blender. That part of the pipeline happens entirely in Unreal for me. Then, once you're importing the file in Unreal, I leave the import setting as is. Everything from skeletal mesh structure to material assignments is handled as expected. That's the real trick here. Most of the issues people run into are caused before the export even happens. The DCC, in this case Blender, is where things tend to go wrong. In Unreal, I just gather the results and double check everything. Material, skeleton hierarchy, physics asset if needed, and so on. If something is off, it's usually because something wasn't right on the Blender side. Finally, for morph targets, if any are missing, make sure you don't have duplicated shape keys names across different mesh parts. Unreal merges the whole character into a single mesh, so if names are duplicated, one may override the other, and you only see one morph target instead of all of them. And this is it for today, guys. Don't forget to really pay attention to every step I showed because it's it's important and it will save you a lot of time, trust me. See you next week for, you know what, a new video. Ciao!